Audio Jungle.
Hello everyone, welcome to the video lecture series of operating systems. In today's session, we are continuing with the topic Deadlock in operating system. Myself, Kunal Pancha, your instructor. In today's session, we are going to discuss deadlock recovery in detail. Before going to discuss deadlock recovery, we need to understand what are the necessary conditions of deadlock, what deadlock means, and what are the different algorithms we have for deadlock detection. And these topics we have already understood in the previous session. Now, once the system is suffering from deadlock, now how we can recover from that situation? Okay, that is nothing but deadlock recovery. Because as you know very well, deadlock is one type of problem, and that needs to be resolved. So you should have some mechanism or there's a technique through which you can recover the deadlock from the system. So let us discuss deadlock recovery in detail. So there are two methods to recover from deadlock. The first one is process termination. Means, as you know very well, when deadlock is entered into a system, once it is entered, means whatever the number of processes which are involved in deadlock situation, in that case none of them processes will able to execute the task. Means nothing will be executed once the deadlock is entered into a system. So no progress will be there when deadlock is there. So how we can recover? And what is deadlock means? As I told you in previous session, means the different processes are waiting for each other to release its resources for its own execution. So if cycle exists, if these four conditions that we have discussed in the previous session, if these four conditions simultaneously true, in that case deadlock will occur. And if you want to recover that situation, okay, so the first approach is what? Can we terminate the processes? Yes, it is possible, because any of the process is terminated, there are chances of recovery as far as deadlock is concerned. So how we can do it? So there are again two subcategories or two different ways through which you can terminate the process, so that you can recover from the deadlock. So the first way or this strategy is to avoid all deadlock processes. Means what? Suppose for example 5 processes are there and 5 processes are waiting for each other to release the resources. Means what? If 5 processes are involved in deadlock processes, so how we can recover it from that situation? So the first approach tells us you need to avoid all the associated processes which is there in the deadlock. Means all the processes needs to be terminated forcefully. But this approach is, we can say, costlier approach. Yes, because if you forcefully terminate all the processes, that is costlier operation in terms of operating system, specifically in terms of resources. Yes, because there are so many resources are associated with different processes, and some of the processes are at the end moment of its execution. Some of the processes are at middle stage of its execution. Some of the processes has initiated its execution. So the different processes are in different state, and if they are associated with this situation, deadlock situation, in that case, this is one approach to terminate all the processes forcefully. In that case, we can recover the deadlock situation, but this is not advisable approach because it is somewhat costlier. So there is a second alternative we have through which we can terminate the process. So that approach is, instead of terminating all the processes which are associated with this deadlock, what we can do is we can abort one process at a time. Okay, so for example, if we have 5 processes which are involved in deadlock, and out of 5 processes, suppose any one process I will pick, okay, and terminate it forcefully. So what will happen? The associated resources of that process would be free, so that there are chances to recover the deadlock situation from it. So abort one process at a time, and what will do once you abort one process, okay, and then you will execute the deadlock detection algorithm, and once it do not detect any deadlock, or once it is in a safe state at the end, it means what, you can successfully recover from the deadlock situation. But if deadlock persists, in that case you need to again abort one more process from the deadlock situation, and again you need to call the deadlock detection algorithm, and again you have to check at the end of execution of the algorithm whether you are in safe state or unsafe state. According to that, you can take the decision whether you have to abort one more process or you can successfully recover from the deadlock situation. So in this way you can recover from deadlock situation as well. So this second approach is less costlier as compared to the previous approach, but there is one disadvantage as far as this strategy is concerned, because this approach is having aborting one process at a time, and afterwards every time you need to call deadlock detection algorithm. So it means what, the overhead would be increased in this case. So one drawback of this strategy is what, it increases the overhead of the system. So but simultaneously the cost would be decreased as compared to the previous approach. So again, if you want to, suppose if we have, as I told you, we have 5 processes which are involved in deadlock situation. So which process, as far as the second strategy is concerned, we are aborting one process, but which process needs to be picked, okay, for termination. So that selection is very important to decrease the overhead and to decrease the cost as well. So how we can pick the victim process, or how we can pick one process through which we can minimize the cost and minimize the overhead. So there are various ways through which we can do these things. So selection of process for aborting is a difficult task, but how we can do it? So there are various ways through which we can do it. So there are following parameters that we need to consider to select one process for aborting. So the first one is we need to consider the priority of that process. Suppose if we have 5 processes, and out of 5 processes, one process is associated with the operating system. Means what, it is a system-oriented process. So definitely that process should not be selected, okay, for abort. Why? Because system processes having higher priority as compared to user processes. So we need to give the priority to user process for selecting as a victim to abort the process. Because if you give the priority to a system process for an abort operation? Definitely. For example, there are two types of processes we have: system processes and user processes, that we have discussed in process management chapter as well, in which we have discussed if one process we have which is associated with the temperature of the system, means what it maintains the temperature of the system. So if you are giving the priority to that process, okay, for abort, so definitely the remaining process, even though it is recovered from the deadlock, the remaining process will not work if the temperature of the system is not maintained. Yes, so priority is one of the parameter to select the process. Okay, second parameter is what percentage of the process finish its execution, means what you should not select a process. You should not select a process which is at the which is at the end moment of its execution. Like say for example, out of 5 processes, say for example 2 processes has completed its execution up to 90%. It is about to finish. So that process should not be selected as a victim. Yes, so that is the second parameter. Third is resource used by a process. So which type of resources, okay, and how many number of resources are used by the process, that again it is our important parameter. So need of resource to complete process remaining operations. Yes, so what type of resource and how many type of resources are associated with that process, according to that we need to select a process as a victim for aborting. Okay, next one is how many processes will need to be terminated. Means if you pick one process, so in that case how many processes would be associated with that. Okay, so again that is important parameter we need to consider. And the last one is process type, which type of process it is. So before picking up one process as a victim, we need to check whether it is batch type of process or we can say interactive process. Yes, because if you say interactive process is what it requires more time for its execution. So you need to give the priority according to this, whether it is batch or we can say interactive process. So these are the various parameters that need to be considered while selecting a victim process to recover from the deadlock situation. Now, next strategy to resolve the deadlock situation is resource preemption. Means we can forcefully preempt the resources which are associated in deadlock situation. So how we can use this strategy? So let us discuss. Sometimes it is possible a resource temporarily take away from its current process and allocate to another processes. That is possible, and that we have already discussed in the process management chapter, in which we had discussed the process state diagram. Sometimes it is possible a resource is temporarily take away from its ongoing executing process and it is allocated to some another process. Like if any high priority process entered into a system, in that case the ongoing execution of a particular process needs to be forcefully preempted. Okay, and give it to the associated resources to a newly entered process for its execution. So that is possible in the case of operating system. So in that case, which resource or which process will be selected as a victim? So selecting a victim for these, we need to consider there are so many factors are associated. So which factors we need to consider to select a victim for it? So one is the priority of the process, as I told you. So if any high priority process is there, okay, so in that case we cannot print that process, because that execution of a high priority process is very important. So if you want to print the process, in that case you need to consider the lowest priority process which are involved in deadlock situation. Second factor is CPU time used by that process. So how much time it is already occupied, or it is already executed in the CPU. According to that, we can select a process. Means what, as I told you earlier in the previous section, if process is at the its end session, that type of process should not be selected as a victim. Okay. The third way, or as a factor, is nothing but number of other processes that would be affected is this process were selected as the victim. Means the other processes, if you pick any process as a victim, so what would be the impact of other processes? According to this, we need to select a process as a process for victim. Now the next strategy is recovery through rollback. The first strategy we have discussed, prevention. Second is how we can recover it from deadlock situation. So recovery through rollback. So what is rollback? I hope you know very well what is rollback. I hope you studied this rollback in database, specifically in transaction control commands. Yes. So recovery through rollback. So in this case, what will happen? So if deadlock situation is occurred, so what will happen? There are two ways through which we can implement this strategy, like rollback to the initial position or rollback to some particular point. So there are two strategies. So if deadlock situation is arrived, in that case you need to undo all the operations that has been performed. Okay, but these operations is again, as I told you, need to restart from the scratch if you roll back like this. Okay, so again it is costly operation. So what we can do is instead of doing whole rollback, okay, what we can do is we can do a rollback up to a certain point, or we say up to certain save point. So what is the advantage of it? So let us discuss on a real life example to understand this concept. Suppose right now you are watching this video and I am preparing this video. So if something going wrong during execution of this process, like say for example, I have already shoot 70% of my video, and if I am at the end moment of my video, and if I did some mistake in it, so what I will do, instead of doing reshoot the whole video, what I will do, it is advantageous, or it is advisable to reshoot that video up to last mistake that I have made in my video. So it is more advantageous as compared to reshooting the whole video once again. Yes, because it contains this number of resources. It requires minimal amount of we can say time for its execution. Yes, so it is less costly as compared to the previous approach in which we need to reshoot whole video from starting, or from scratch. So that is not advisable. So we can recover the deadlock situation by two different ways as far as rollback is concerned. Either we can roll back to the last save point, or we can say we can roll back the whole scenario. Okay. Now the last one is starvation. So to pick one process as a victim, So once you select a particular process as a victim, and after some time, again if deadlock situation is arrived, so it is not advantageous to pick the same process again and again as a victim, because if you are doing this strategy or if you are following this strategy, definitely it leads to a starvation. What is starvation means? In that case, that process will never execute in the CPU. So it will never terminate from the system. It will always in waiting state, or always in waiting mode. So to avoid this starvation, what we can do is we can put some threshold value through which we can avoid this situation called starvation. So what we can do in this case, suppose maximum 5 times, 5 is my threshold value, maximum 5 times I can pick the same process as a victim. That is the maximum value. Okay, if you reach that value, then in later cases you cannot consider that process as a victim. Yes, so these are the various approaches through which we can recover from the deadlock. So I hope it was clear to you. Thanks for watching this video. See you in the next one.